Hello, welcome to Predicting the Weather in Indianapolis using AI. Meet our team. I'm Sam.
I'm Jack.
I'm Anthony.
I'm Josh.
And I'm Luke.
And we are Team 15. Thank God I abandoned Thomas.
Yes, sir.
And so this is our quick rundown of our agenda, where we'll go over the problems and motivations, our specific approaches, the design of our system, and then we'll have Anthony show a quick demonstration, and then we'll go over what we learned and do our reflections.
So why weather? As we all know that the data in Indiana is very changing. It can be snowing one day, very hot one day. It's always changing and we want to know how to predict it. So why is this going to help us? So Indiana weather is similar to West Lafayette, so we're going to use data from there and apply it here. It'll be useful to all Purdue students. It's seemingly unpredictable because Indiana weather has rapid changes, as seen in the last slide. It's raining, snowing, hot, whatever. And then since that, it can be really hard to predict the weather for each day of the week. And overall, this will be helping everyone's plans, as it can help people plan, make trips.
So specific approaches that we did while going through this process was we went to the National Centers for Environmental Information Climate online database. We looked through that to try to find all of their weather data, and we selected a select few to try to go through all of that. Instead of going through every single year and all the days and everything, we just selected a couple weeks or months to go through the data so it wouldn't take forever. And then we data wrangled to make sure all the data is usable to go through the model, and then made sure it is easily formatted and usable through Google Sheets.
For the process of the design, we found suitable data about weather patterns in Indianapolis, Indiana, because as mentioned before, there was not much data for West Lafayette and Lafayette as compared to Indianapolis. For the data itself, we obtained and compiled data neatly into a CSV file. We trained a model that can utilize data to make fairly accurate predictions. We tested the model to determine the degree of accuracy, and the revision had us tweak and or fix the model code to ensure a greater accuracy of weather predictions.
Hey guys, Anthony here to give a brief overview and demonstration of our model code. We begin by importing the data from our CSV file and putting it into a pandas data frame. Next, we process the data to drop unnecessary columns like metadata and other unimportant attributes so that we're left with 11 columns overall. Then we interpolate between values to try and fill any missing values, and then drop any rows that still have missing values at the end. Next, we further process our data to generate a training set and a testing set. Each training set will contain, for each row, 7 days worth of weather data to train on, followed by the day afterwards, whose weather we want to predict. So in total, we will have 77 features to train on and 11 features to predict. Next, we train our model. We use a neural network for the fit, as it's very good at handling temporal data like this weather data. And to optimize our hyperparameters, we use Bayesian optimization search, as it's significantly faster and more efficient than grid search. To create predictions for each of our 11 outputs, we train a separate neural network regressor for each, and then fit it to the data as shown here. Once we're done, we can save it to a file. And if we already have a pre-trained model, we can import it using this code here. Then we can make predictions like so for any given day in our dataset, and then we can evaluate our predictions using mean squared error and average relative percent difference. And the lower the mean squared error and the lower the relative percent difference, the more accurate our predictions are.
And overall, we found our model was very good at predicting temperatures. For average temperature, we only had an 11% median relative difference. For max temperature, we had about a 10% median relative difference, and for a minimum temperature, about a 32% median relative difference. We were also quite good at predicting wind speed as well, along with wind direction. We found that the calculations for average wind speed, fastest 2-minute wind speed, and fastest 5-second wind speed all had a median relative difference of about 20%. In addition, we found that the direction predictions had a median relative difference of about 30%. Where our model failed, however, was in the precipitation calculations, where we found that the predictions for precipitation, snowfall, and snow depth all had relative differences of 100%, meaning it was just completely off.
What we learned from this, so we learned about using our previous data to make sure that we're having somewhat accurate weather predictions. So with our March Madness project, we went through and we used similar lines of code to ensure that we had similar levels of accuracy for this one. With our neural networks, we made sure that with our formatted data, we had easy predictions that were logically based, and alongside with our CSV file, we made sure that everything was neatly organized and readable by everyone else. And some of the challenges that we had was in that formatting of the data, because we had to make sure that everything was nicely labeled and we had to make sure that everything had all the data and that it was correct. And it was just a little bit of a pain to make sure to go through and cross-check everything to make sure everything was as accurate as it could be.
Thank you.
Thank you.
We are the O.J. Simpson fan club signing off.